Hi, in this video, we are going to look at some more inequalities and mostly we'll look at a few techniques of problem solving, especially the technique of substitution. So we'll start off with the problems. The first one says, suppose x, y, and z are positive numbers and we have x plus y plus z is equal to 1 by xyz. We have to the minimum value, find the minimum value of x plus y multiplied by y plus z. So let's think about this problem. We want to look at this condition and figure out what we can deduce from this condition. If you write this condition like this, x plus y plus z multiplied by xyz is equal to 1, then this should remind you of something. Uh, if if x plus y plus z multiplied by xyz is 1, then obviously root over xyz x plus y plus z is also equal to 1, right? So if you recall Heron's formula for area of a triangle is given by root over s, s minus a, s minus b, s minus c. So this looks very similar to this expression, except s should be x plus y plus z and s minus a should be x, s minus b should be y, and s minus c should be z, right? So basically, if we think of the inequality here and think of it in terms of a triangle, then we'll realize that we can deduce that the sides of that triangle ABC can be given as x plus y, y plus z, and z plus x. If you have a triangle with these sides, A is equal to this, B is equal to this, and C is equal to this, then you should easily realize then the S will become x plus y plus z, and S minus A is, in this case, it is z. S minus B is basically x, and S minus C is y, right? So then we have, in this triangle, we have this result, which implies that uh, we have root over x plus y plus z into x plus y plus z is 1. Now what is x here, right? X is basically what? X is s minus a. We have already written that, and y is s minus b, and z is s minus c. So this is saying that the area of the triangle is 1, right? If the area of the triangle is 1, we can write the area in a different way also. Area del can be written as half into BC sine A is equal to half into CA sine B is equal to half into AB sine C, right? And the area is equal to 1. So what is x plus y? That is A. And what is y plus z? That is B. So we can write the area del is half into AB sine C, and area is 1, so we get AB is equal to 2 by sine C. AB is coming as 2 by sine C, and what is A and B? A is x plus y and B is y plus z. So we are getting x plus y into y plus z is 2 by sine C, which is clearly greater than equal to 2, because sine C is less than equal to 1. So we have gotten the minimum value of this product, and that is greater than equal to 2. The question has been very easily solved just because we hit upon the right substitution. The right substitution is this substitution where we say x plus y is z, x plus y is a, y plus z is b, and z plus x is c. And this substitution is known as the tangent length substitution. So if you have a triangle like this, triangle A, B, C, and we have this side is A, this side is B, this side is C, and we have a in circle like this, we can always say that this distance is x, this distance is x, and this distance is y, and this distance is y, and these two tangent lengths are z and z, right? And from here we get a is equal to x plus y, b is equal to y plus z, c is equal to z plus x, and obviously semi-perimeter is equal to x plus y plus z. So this substitution, where we say the sides of the triangle are written in terms of the tangent length, the length of the tangent from B and C and A respectively, is called the tangent length substitution. In this problem, the problem was very easily solved when we did this substitution, because we could spot that the expression in the problem, which was xyz times xyz, x plus y plus z, equal to 1, this expression looks so much like the area of the triangle, right? Sometimes in problems, you might have to do the inverse substitution. The inverse substitution would be x written as a plus c minus b by 2 and so on, y written as b plus c minus a by 2, and z is written as a plus b minus c by 2. Sometimes the inverse of this substitution is also useful. However, in this problem, we have shown you a method where the direct substitution is helping us solve the problem, right? Let's move on to the next one. Question number 2. It says that let x1, x2, and x3 be positive numbers. Be positive numbers. We have to show that x1, x2, x3 is greater than or equal to x2 plus x3 minus x1 multiplied by x1 plus x3 minus x2 multiplied by x1 plus x2 minus x3. So this is very similar to the first question. You just have to hit upon the right substitution. Here I would say this is A, this is B, and this is C. And then we have to prove basically that x1 is B plus C by 2 we get, x2 is C plus A by 2, and x3 is A plus B by 2. And you can easily see that this product is the product of B plus C, C plus A plus B by 8 is greater than or equal to A, B, C. That is obvious from AMGM inequality. B plus C is greater than or equal to twice of root BC and so on. The only thing you have to be careful of here is ensure that x1 and x2 and x3 have to be positive, right? So we can only apply AMGM if everything is a positive quantity, right? So here we can assume that since these three are positive, the whole product here is positive, and the product here will be positive when two of the brackets are negative and one is positive, or all three are positive, right? So those cases you have to just check one. So I will leave that uh, discussion to you. You can figure it out when this substitution is valid. Uh, However, the problem is solved easily once you hit upon the right substitution, and it's a direct AMGM problem after that, right? Let's look at the next one. Question number 3 says, assume that there are that n positive real numbers, a1, a2 to an, where n is greater than or equal to 3, satisfy 1 by 1 plus a1 power 4 plus 1 by 1 plus a2 power 4 and so on till 1 by 1 plus an power 4 is equal to 1. We have to prove that the product of a1, a2 till an is greater than or equal to n minus 1 to the power n by 4. Now in this question again, we have to think of the right substitution. So what I would say here is, let's say 1 by 1 plus a1 power 4 is equal to x1, right? So that implies a1 power 4, if you solve for that, is becoming 1 minus x1 by x1, right? And let's focus our attention on this product, right? So if I multiply a1 power 4 into a2 power 4 and so on till an power 4, I'm going to get that is equal to 1 minus x1 by x1 multiplied by 1 minus x2 by x2 multiplied by 1 minus x3 by x3 and so on till 1 minus xn by xn, right? These products are coming, correct? Now, these products actually can be written as, okay, I have missed writing this condition. I think we have x1 plus x2 plus xn is equal to 1. We had this condition. Is x1 plus x2 plus till xn equal to 1? If that condition is true, let's just check that condition. Yeah, actually, I forgot about thinking of this condition because we have xi is equal to this and this condition was given. So that implies this, right? Correct. So x1 plus x2, the sum of all the xi's is equal to 1. So when I rewrite this product here, think about it, 1 minus x1 will look like this, x2 plus x3 till xn by x1. What will be 1 minus x2? 1 can be written as this, minus x2 means you will miss the second term, x1 plus x3 till xn by x2. And similarly, this product is created here, right? So I will just write it on the next screen. I have a1 power 4, a2 power 4 till an power 4 is equal to x2 plus x3 plus xn by x1 multiplied by x1 plus x3 till xn by x2 and so on till we have last term is x1 plus x2 till xn minus 1 by xn, right? Now at this step, I can do AMGM inequality on each of the terms in the numerator here, right? This is AMGM on n quantities, right? So this is going to be greater than equal to n minus 1. Actually, it is on n minus 1 quantities because one quantity is missing. X1 is missing from the first bracket. So there are n minus 1 terms here. So that is greater than equal to n minus 1 into x2, x3, xn whole to the power 1 by n minus 1 multiplied by this term will be greater than equal to n minus 1 multiplied by x1, x3, xn whole to the power 1 by n minus 1 and so on. This term is x1, x2 till xn minus 1 whole to the power 1 by n minus 1 divided by x1, x2 till xn product, right? Now think about this. This is equal to, there are n terms actually, so it is becoming n minus 1 power n. And what is coming here? Each of these brackets basically has one term missing out of 1 to n, right? Here x1 is missing here, and then x1 is present in all of the rest of the terms, right? So you will get out of the n parenthesis, you have n minus 1 bracket in which x1 is present. So the power of x1 will be x1 power n minus 1 by n minus 1, right? Similarly, x2 power n minus 1 by n minus 1 and so on. You will get xn minus 1 power n minus 1 by n minus 1, right? And you also get a xn because xn was present in all the other terms except the last term. And this you divide by x1, x2 till xn, you will realize that these are all power 1. And this gets completely cancelled. This whole term here gets cancelled with the denominator. So you're getting equal to n minus 1 power n. This term is equal to. So you can say that a1, a2 till an, the product, whole power 4, is greater than equal to n minus 1 power n. And we have gotten that the product of I goes from 1 to n, an is greater than equal to n minus 1 power n by 4, right? So actually the question was easy, even though it looked really strange. The condition that we had to prove, it was immediately solved if you hit upon the right substitution. We said 1 by 1 plus ai power 4 is xi, and then we solved for ai power 4 and then multiplied all the ai's, and we got an inequality involving x's, right? And at one step in the inequality, we applied AMGM on n variables and got the inequality that we desired, right? So hopefully you learned something from this one. Let's go to the next problem. This is question number 4. We have, if A, B, C, let A, B, C be positive real numbers satisfying ABC equal to 1, we have to prove that 1 by 1 plus 2a plus 1 by 1 plus 2b plus 1 by 1 plus 2c is greater than equal to 1. Now this is the type of question that you will see many times. Since a into b into c is given as 1, we have to think of an appropriate substitution that simplifies this problem for us. So this is a cyclic substitution. If a and b and c are 1 and they are not equal to 0, since a, b, c are positive, none of them is equal to 0, we can obviously take the substitution a is equal to x by y, b is equal to y by z, and c is equal to z by x. You can see that the product of these three becomes 1, and this substitution is valid because none of the numbers a, b, or c could be 0, right? So there is no issue of x or y or z becoming 0. So if I put this substitution in the problem becomes starts looking like this: y by 2x plus y plus z by 2x plus 2y plus z plus x by 2z plus x is greater than equal to 1. We have to show this now, right? Now at this stage, what I would do here is apply Cauchy's inequality. So if you recall, Cauchy's inequality says something like this: a1 square plus a2 square plus a3 square multiplied by b1 square plus b2 square plus b3 square is always greater than equal to a1 b1 plus a2 b2 plus a3 b3 whole square, right? This is my Cauchy's inequality, and I want to apply it on two terms. One term that looks exactly like this, and one term that helps us simplify this question. So let's see. The second term for Cauchy that we'll use is this: x into x plus 2z plus y into y plus 2x plus z into z plus 2y. And this multiplied by the terms that we need, which are x by x plus 2z plus y by y plus 2x plus z by 2x plus z by z plus 2y. Think about it. Uh, I want to do Cauchy inequality where this is my a1 square and this is my b1 square. This is my a2 square and this becomes my b2 square, and this is my a3 square and this is my b3 square. Now you can see the pattern here. You have a1 square plus a2 square plus a3 square multiplied by b1 square plus b2 square plus b3 square should be greater than equal to what we will get inside the bracket. We will get a1 times b1, which is root x times root over x plus 2z multiplied by root x by root over x plus 2z, which root over x plus 2z gets cancelled and you end up with just simply x plus y plus z whole square. You can check whether this is coming or not You can basically calculate a1 b1 plus a2 b2 plus a3 b3 whole square, and you will get x plus y plus z whole square here, right? So what we are ending up getting is basically this expression. I'll just write it on the next screen. I'm getting x into x plus 2z plus y into y plus 2x plus z into z plus 2y multiplied by x by x plus 2z plus y by y plus 2x plus z by z plus 2y is greater than equal to x plus y plus z whole square. Now, if you think about it, this term here is actually x plus y plus z whole square itself. If you expand this, it is x square plus y square plus z square plus 2xz plus 2xy plus 2yz, right? So this term is coming like this. We have x by x plus 2z plus y by y plus 2x plus z by z plus 2y is greater than equal to x plus y plus z whole square here. So we cancel off this term and we are getting that our desired inequality x by x plus 2z plus y by y plus 2x plus z by z plus 2y is greater than equal to 1. Notice how we use the Cauchy inequality here. I want to prove that it is greater than 1. So I had a fraction x by x plus 2z. I need to cancel some stuff. So I took terms like x into x plus 2z as the other bracket for the Cauchy, right? So we are eventually being able to prove the desired inequality. This, if you convert back to the old variables, you'll get 1 by 1 plus 2a plus 1 by 1 plus 2b plus 1 by 1 plus 2c is greater than equal to 1. So that solves this question. Let's move on to the next one. The question here is stated as follows. We have real numbers a, b, and c. Real numbers a, b, and c satisfy a plus b plus c is equal to 1 and ABC is greater than 0. ABC is greater than 0. We have to prove that AB plus BC plus CA is less than root over ABC by 2 plus 1 by 4. We have to show this inequality. AB plus BC plus CA is less than root over ABC by 2 plus 1 by 4. The conditions of the problem are saying that real numbers ABC are such that a plus b plus c is equal to 1 and also ABC is positive, right? So let's think about it. Since ABC is greater than 0, we can have one positive number and two negative numbers out of A, B, and C, right? Let's assume that A is greater than 0, whereas B and C are less than 0. Just to think about this case, right? If A is greater than 0 and B and C are less than 0, then AB plus BC plus CA can be written as B times A plus C plus AC, right? Now, B times A plus C plus, we know for sure here that AC is negative, right? Because A is greater than 0 and C is less than 0. So obviously B times A plus C plus AC would be lesser than B times A plus C, right? And B times A plus C is basically equal to B times 1 minus B, right? And you should realize that 1 minus B will be positive because B is less than 0 and B is negative. So this thing is less than 0, right? So we are able to show that AB plus BC plus CA is less than 0 if A is positive and B and C are negative, right? Now, if it is less than 0, it will automatically, it satisfies the inequality, right? Satisfies the inequality that we want to prove. We want to show that AB plus BC plus CA is less than root over ABC by 2 plus 1 by 4. Obviously, if it is less than 0, it is automatically satisfying this inequality, right? So basically, we have shown that in the case where two numbers are negative and one number is positive out of ABC, the inequality is true. So now I want to prove the inequality for the case where A, B, and C are all greater than 0. That is the other case where all three have to be positive, because we have been given in the problem itself that ABC is greater than 0, right? So if ABC are all positive, then without loss of generality, we can assume that A is greater than equal to B, is greater than equal to C, is greater than 0, right? And if this is true, since since A plus B plus C is equal to 1, we can assume that it implies that A is greater than equal to 1 by 3 and C is less than equal to 1 by 3. Because A is the largest number and C is the smallest number, A plus B plus C will be greater than equal to, will be less than equal to 3A. Therefore, 1 is less than equal to 3A. So A is greater than equal to 1 by 3. And you can easily show that A has to be greater than equal to 1 by 3 and C has to be less than equal to 1 by 3. So keep this in mind, and now we go on to the next screen where we will discuss the inequality itself. So let's say the inequality that I want to prove is AB plus BC plus CA is less than equal to, is less than root over ABC by 2 plus 1 by 4. Keep this in mind. We will start by looking at the expression AB plus BC plus CA minus root ABC by 2. Okay. Now this is equal to C times A plus B. This accounts for the terms AC plus BC, right? And then we can take a root AB common between this term and this term, and you will get a root AB minus root C by 2 inside, right? Great. And since we know already that A is greater than equal to 1 by 3 and C is less than equal to 1 by 3, it implies that root AB would be greater than equal to root B by 3, right? I mean, you should actually get root A is greater than 1 by root 3 and then root A B should be greater than equal to root over B by 3, right? And that should be greater than equal to root over C by 3, correct? And similarly, we should also have by AMGM, we should have root AB is less than equal to A plus B by 2, right? Which is root AB is less than equal to 1 minus C by 2, right? We should have these inequalities here, correct? So we have one condition on root AB here and one condition on root AB here, right? We want to use these conditions here in this step. So I want to say that C times A plus B is equal to C times 1 minus C plus root AB minus root C by 2. And now I'll apply conditions on root AB here, right? So I'll say this is greater than equal to, not greater than equal to. We will say that C times 1 minus C plus root AB into root AB minus root C by 2 is less than equal to C times 1 minus C plus, instead of root AB, I can write 1 minus C by 2. And here also I can write 1 minus C by 2 minus root C by 2, right? So at every step where we had a root AB, I replaced it with this inequality. Root AB is less than equal to 1 minus C by 2. Okay. Now simplifying this expression, we'll get a equation in terms of C. So this is equal to C root C by 4 plus C by 2 minus 3C square by 4 plus 1 by 4 minus root c by 4, right? Now it is enough for us to prove that this quantity, if we prove that this quantity is less than 0, the original inequality is already proved, right? Because we have to actually show that it is less than 1 by 4, right, in the original inequality. So our job is to show that this quantity is less than 0. And if we can show that something greater than that, or basically this quantity is less than 0, we are done, right? If we can show this is less than 0, that will imply this is less than 0, and that will imply this, right? So I want to prove the expression here that I'm getting in terms of c is less than 0. So I'll do that on the next screen. So I'll write it down. It is coming like this: minus 3c square by 4 plus c root c by 4 plus c by 2 minus root c by 4 plus 1 by 4. Now I have to show that it is less than 0. Now multiplying by my negative sign throughout, you get 3c square by 4 minus c root c by 4 minus c by 2 plus root c by 4 should be greater than equal to 0, right? I missed a 1 by 4 here. So I'll just put a plus 4 minus 1 by 4 should be greater than equal to 0, right? Correct. So let's think of multiplying by 4 throughout. You will get 3c square minus c root c minus 2c plus root c minus 1 is greater than 0. We need to prove this, right? So, okay. So, what I already have here is basically I can show that I need to show this is positive, and the way we will do it, I think, is look at this expression. This expression, if you take root c as t, you're getting 3t power 4 minus t power 3 minus 2t square plus t minus 1 is greater than 0. Now this function is positive, we need to show. So we already know that 0 is less than c is less than equal to 1 by 3. So we know that root c is less than equal to 1 by root 3, right? So t is less than equal to 1 by root 3. We already know that. We also have this implies basically that t power 4 will be less than equal to 1 by 9, right? So 3t power 4 is less than equal to 1 by 3, correct? So 3t power 4 is less than equal to 1 by 3 is coming. We can also say that if we want to compare this t cube and t, we can say that actually the best way to prove this inequality would be just by doing a little bit of calculus. We have t is less than equal to 1 by root 3, and in that region we need to check this function. So let's see what is the derivative of this function. We have 12t cube minus 3t square minus 4t plus 1, and the double derivative is becoming 36t square minus 6t minus 4. So this double derivative is having two real roots. Uh, t goes from 0 to this. 0 is less than t is less than 1 by root 3. In this region, the double derivative is what? 0 to 1 by root 3. We have the quadratic is like this, and the roots of this quadratic are t is equal to 6 plus minus root over 36 minus minus plus 16 into 36 by 2 into 36. So we can easily see that it is 6 plus minus 6 root over 17 by 2 into 36. So 6 gets cancelled. You have 1 plus minus root 17 by 12. So the root, one of the roots is negative and the other root is 1 plus root 17 by 12, which is less than 1, right? So 1 plus root 17 by 12. And root 17 by 12, if you multiply here by 4 root 3, 4 root 3, you are getting 4 root 3 by 12, and 4 root 3 will be root over 48. So this root is somewhere here. So my root here is somewhere here, and the value of the derivative is negative. C lies before one of the roots. I feel like I've made a simplification mistake at some stage here. I will just check my calculations once again. So I had basically this expression c times 1 minus c plus root ab into root ab minus c by 2, root c by 2. And this was less than equal to c times 1 minus c plus 1 minus c by 2 and 1 minus c by 2 minus root c by 2. And this became c square minus c square plus c plus 1 plus c square minus 2c by 4 minus 1 minus c root c by 4. So this became minus c square plus c plus 1 by 4 plus c square by 4 minus c by 2 minus root c by 4 plus c root c by 4, right? So this came out to be minus 3c square by 4, this and this got cancelled, plus c by 2 plus c by 2 minus root c by 4 plus c root c by 4 plus 1 by 4, right? And I have to show that this quantity is less than 0. So if I multiply by 4 throughout, I get a minus 3c square plus c by 2 into 4 minus root c plus c root c plus 1 is less than 0. So this is minus 3c square plus 2c minus root c plus c root c plus 1 is less than 0. Multiply by minus 1, so we get 3c square minus 2c plus root c minus c root c minus 1 is greater than 0. I need to prove this, and now I can compare uh, 3c square and c root c. I can compare 3c square and c root c. Okay. Uh, I'll write 3c square Hmm. I need to prove that this is greater than 0. And for that, I can write it as 3c squared minus c minus c plus root c minus c root c minus 1 is greater than 0. This part is c times 3c minus 1, right? And I know that c 0 is less than c is less than 1 by root 3. So therefore, 1 by 3 minus c is greater than 0. So we have 1 minus 3c by 3 is greater than equal to 0. So basically, I have 3c minus 1 is less than equal to 0, right? This is 3c minus 1. This is less than 0. This is, yeah, this is negative actually. Correct. And we can also do AMGM, and we can say 3 times c root c plus 1 by 3 plus 1 by 3 will be greater than equal to 3 times cube root of 3 3c root c into 1 by 3 into 1 by 3, and you will get that is equal to 3 goes inside 27 cube root of 3 9 c root c, right? So this becomes mm, cube root of 9 and c power 3 by 2, so root c. So I'm getting this quantity 3 times c root c plus 2 by 3 is greater than equal to this, right? 3 times c root c plus 2 by 3 is greater than equal to cube root of 9 into root c, right? Uh, there is some issue with this inequality, this last step. I have still not been able to prove this. So what I'll do is I'll look at, maybe I'm making some silly mistake at some stage. I'll just look at it once more and we'll solve this in the next inequality video, right? Try it out yourself. I feel like I've made some mistake somewhere because of which I'm not able to prove this part. Uh, we have c is less than equal to 1 by 3, and in that region we have to prove this. Mm, yeah, there is some issue here. I'll try it out and we'll probably get a different proof of this also. Uh, why don't you also try this question once more yourself? And we'll look at it and solve it in the next video. So don't worry about that. But keep in mind that the whole point of the class was inequalities by substitution. We used substitution method in several of the problems before to try to solve the question. And you should employ this substitution technique in inequalities problems. So that is a common strategy. Uh, Work on this problem once. I will also try it and we'll solve it in the next video. Right? I'll see you next time.